Hi everyone. I know everyone is quarantined, but by God's grace, we all are with our family. But I know that being with the family for so long can cause certain reactions. So why not study something related to it? So this is Vamakshi, and today we'll see some topics related to chemical kinetics.
हे गाइस सो ये क्वारंटाइन में हम ऑलरेडी बहुत सारे टाइप के रिएक्शंस देख रहे हैं। फ्रेंड्स के साथ नोक जोक, उनके साथ अच्छी बातें, सिबलिंग्स के साथ कोल्ड वॉर, मम्मी पापा की डांट, बहुत सारे रिएक्शंस हम क्वारंटाइन में देख रहे हैं। सो थोड़ा सा हम केमिस्ट्री के रिएक्शंस भी अब देख लेते हैं। लेट्स स्टार्ट विद आवर फर्स्ट चैप्टर विच इज़ योर केमिकल काइनेटिक्स and this is presented by me and Vamakshi. Okay, so I'll start the chapter and first introduce you with the name. So the chapter's name is chemical kinetics, and I'll differentiate the words into its specific meaning. So chemical is all about reactions. Now, what are reactions? We have already studied many kind of reactions. Reactions involve two things. First one is product and second one is reactant. Reactants are written on the left hand side and products are written on the right hand side. There's an arrow in between which indicates the direction of the reactions. Okay. Now, kinetics is nothing but speed, and here I have written a word in the brackets which is rate. And speed and rate are the two words interlinked with each other, and I will relate it in the next slide. So first we'll see what the chemical kinetics is and what are the factors of studying, what are the factors in which what are the factors that we study in chemical kinetics. Okay, so here's a picture depicting some reaction. The two reactants are getting mixed up, and the product is the color change of the solution. You can see the color changes so fast, and it changes so many colors that reaction here, the reaction which you look here is very fast, and every chemist wants that the reaction have to be fast. अब why the reaction have to be fast? Oh come on यार, तुम लोग भी लैब में खड़े रहोगे, एक रिएक्शन करने के लिए बोला तो तुमको चाहिए कि 5 मिनट में, 2 मिनट में हो जाए। 5 मिनट तो बहुत दूर की बात है। तो बस वैसे ही सारे केमिस्ट को भी चाहिए होता है कि उनके रिएक्शंस काफ़ी ज़्यादा फास्ट हो। तो फास्ट कैसे होंगे? अगर कोई रिएक्शन स्लो है तो फास्ट कैसे होगा? अगर फास्ट करना है तो कौन से फैक्टर्स डिपेंड करते हैं? प्रेशर डिपेंड करता है, टेम्परेचर डिपेंड करता है, कॉन्सेंट्रेशन डिपेंड करता है, बहुत सारे फैक्टर्स होते हैं। कौन से फैक्टर्स कैसे डिपेंड करते हैं? केमिकल काइनेटिक्स में क्या स्टडी होगा, स्पीड करना है, क्या करना है, वो सब कुछ हम केमिकल काइनेटिक्स में देखने वाले हैं। Okay, so सबसे पहले I'll show you the factors that you will study in your chemical kinetics. So these are some points which you are basically going to study in chemical kinetics. सबसे पहले देख लेते हैं कि chemical kinetics का definition क्या बोलता है. Chemical kinetics is nothing but the branch of chemistry which deals with the rate of the chemical reactions and the factors those affected. Now, how it deals with the rate of the chemical reactions? It deals only and only that how fast the reaction proceeds. अगर वो reaction fast नहीं जा रहा है तो हम उसको fast बनाएंगे. Okay. Second, it gives the information about the chemical changes. Now, what kind of chemical changes and what is the mechanism? Mechanism is basically seen in only complex kind of reactions. Complex reactions in the sense when the reaction takes place in 2 to 3 steps or more than that. So that reaction becomes a complex reaction, and complex reactions has some mechanism. Third point is it predicts how rapidly it approaches the equilibrium. Now, what is an equilibrium? You have already studied chemical equilibrium in your 11th standard. Now, chemical equilibrium में तुमने क्या पढ़ा था कि रिएक्शन जो है, एक अगर रिएक्टेंट प्रोडक्ट बनता है तो प्रोडक्ट तुरंत वो रिएक्टेंट भी बनता है। हम नॉर्मल रिएक्शंस में एक एरो डालते हैं, बट हम इक्विलिब्रियम के रिएक्शंस में बैकवर्ड फॉरवर्ड 2 एरोज डालते हैं वहाँ पर. Okay, so it is nothing, it also predicts, it also helps to predict the equilibrium also. ये सारे points जो हैं, ये this is nothing but These are nothing but the points that you are going to study in your chapter. Okay, so I'll first go with the word rate and define it more accurately what the word rate is and how it is defined. Okay, rate. So what is rate? So I'll relate this word rate to speed. Now, how it is related to speed, I'll just show you in a picture. Whenever we buy any kind of vehicle, the thing we see is the speed, how fast or how slow the car is moving. This car is moving very slow, I know that, but assume it is moving very fast. So the formula for speed in physics is speed is equal to distance upon time. That is, the distance traveled per unit time is nothing but your speed. Now, because this was physics, so we were measuring the speed of any kind of machine. But here, because we are studying chemicals, we are studying reactions. So here, I'll relate this word speed to the word rate. Now, what is rate? Rate is nothing but it is a change in chemical concentration of reactants or products per unit change in time. Now, this definition, I'll clarify it. I'll give you the definition, proper definition also. But here, I just wanted to relate it with speed. Uh, Speed is the word used in your physics, but rate is the word used in your chemistry. Okay, rate measures the change in the chemical behavior, and speed measures the how fast or how slow your vehicle or your machine moves or works. Okay, rate and speed, both the words are same, but rate is used in chemistry and speed is used in the physics term. Okay. Okay, so first I'll give you the definition of average rate, and average rate is nothing but it can be described by knowing the change in concentration of reactants or products divided by time interval over which the changes occur. Now, every statement here has some mathematical expression, and I'll give you the mathematical expression and then I'll explain you about the average rate. So this is your mathematical expression where you can see it in your screen that rate is written as delta A divided by delta time. Now I'll explain you every term involved here. Rate is nothing but the speed that we are measuring the speed of any kind of reaction equals to आपको पता है क्या होता है delta delta is nothing but change in okay delta indicates change in square brackets it is written here also I am also saying square brackets are compulsorily written for the concentration square brackets are used to indicate that you have written concentration and here in rate equations, normally we use concentration in terms of molarity. Molarity is a term in which we measure concentration, okay? And it is nothing but divided by delta time. Now, delta again is change in and time is time, okay? A is written as it can be reactant or it can be product. Now, why it can be reactant and why it can be or it can be product? I'll explain you this you can look at this picture. There's a reaction given. A is a reactant, and the reactant goes to product B. Okay. Now here, if you see the reaction, logical सी बात है कि A is being consumed and B is being formed. Okay, because A was the reactant. By the time goes, A being the reactant, it is being consumed, and B being the product, it is being formed. Okay, so at the time at initial time A was 100%, at final time B should be 100%. So average rate of consumption of A is equal to minus delta concentration of A divided by delta T, that is time. Okay, now why that negative sign is given? I know the statement is written over here, but still I'll explain you that negative sign is given because the concentration of A is being decreased. Why it is being decreased? It is a reactant, and by the time goes, the reactant has to decrease so as to form product. and because products are being formed, so there is a plus sign. This negative and plus sign is just to indicate that they are being consumed or they are being formed. That I'll give you an example. This example where A was reacting to give you product B, this was very simple, very general kind of reaction where there were no stoichiometric coefficients used. But now I'll give you a more complex type of reaction where the stoichiometric coefficients are also used. Now, I hope you know this. What is the meaning of stoichiometric coefficients? Those are nothing but the balancing figures that you substitute or you put before your reactants or your product just to balance the chemical equations. Okay, and you have done this in your school times, balancing the chemical equations. Okay, so here the reaction is A, capital A plus B, capital B will give you C, capital C and D, capital D. Okay. Now small a, B, C, D indicates your stoichiometric coefficient. That is nothing but the numbers or the figures which are used to balance the chemical equation. Now, how do we write the average rate of the reaction? Average rate of the reaction is written as you see in the last picture, that is delta A divided by delta time. Here also it is written as it is, but here we have written minus 1 upon A, minus 1 upon B, 1 upon C, 1 upon D. Why this stoichiometric coefficient is being divided? The reason here is that the amount of A consumed or the amount of B consumed or the amount of C formed or or the amount of D formed has to be equal. When we say that it is the average rate, we are saying that it is the average speed, and average speed of the reaction has to be equal with every concentration like A, B, C, and D has to be the same, because we cannot say the average rate of the reaction for reactant A is different, for B it is different, for C it is different. No, we have to generalize it and we have to say that average rate of the whole reaction is so and so. So we just divide it by the stoichiometric coefficient so that we equalize the equations. Okay, it is just to equalize the equation and we divide it with the stoichiometric coefficient. Now below that you can see that rate of disappearance of A, again the same thing is written, of A is delta concentration of A divided by delta T. Disappearance of B is written appearance of C, appearance of D. Now don't get confused with the word disappearance or consumption. Disappearance and consumption both are same in this whole thing. Okay, appearance and formation both are same. Okay, I again repeat that square brackets is not at all used for the fashion purpose. Okay, and that square brackets is used to indicate that you have written concentration. As you can see in the time t, we have not used this that square brackets because it is not concentration. And A, B, C, and D were concentration, so we have written those terms in square brackets. Now we have not also written square brackets in small a, b, and b, c, d. Why? Because those are also not concentrations, those are just the stoichiometric coefficients. Okay, guys, I hope this part is clear with you all. Okay. I'll move to the next part of rate, which is nothing but your instantaneous rate. Now, what is instantaneous rate and what was average rate? Average rate was measured when you have only two figures, like final and initial. So you just find the difference between the two and you find the average rate. Like it is just like you find the speed of any vehicle. Okay. Now, what is instantaneous rate? Instantaneous rate is found out when the reaction is being processed, okay, and you have to find out the rate in the between of the reaction. Like suppose I have started my reaction at time t is equal to 0, and I have to find out the rate or the speed of the reaction at time t is equal to 10 seconds. So what will I do? Okay, because I don't have the concentration. What would be the concentration at time t is equal to 10 seconds and the rest things. So what we will do? So here is the definition for it. It is nothing but to determine the instantaneous rate of the reaction. The progress of the reaction is followed by measuring the concentration of reactant or product for different time intervals. We find out the instantaneous rate by plotting a graph. Now, this graph is all about your instantaneous rate. Guys, in your 12th standard textbooks, this graph is differentiated into two, reactant and product, but I have used only one picture, so don't get confused here, okay? You can see that on y-axis concentration is plotted, on x-axis time is plotted. You can see two curves there. One is of product and other one is of reactant. So first I'll explain you what is reactant curve all about, and then we'll go with the product one. Okay, so when time t was 0 seconds, like when time t was 0, when I started my reaction, so the concentration of reactant was 0.1 mole. That is your 100% reactant it was at that time, because I had used all my reactant there. Okay. So as the time proceeds, the reactant decreases, or it is being consumed, or it is being disappeared. Okay. So the reactant curve decreases down exponentially. Okay. And you get a curve. Okay. So it was 100%, and with the time, as the time goes on, it decreases and it comes to almost zero. Okay. Now, the same thing is applied to the product. When time t was zero, the product's concentration was zero because the product was not being formed when that reaction was started. But as the reaction was started, product had been started formed, and then the curve you can see that it is increasing continuously. Okay, so at the initial time, the product's concentration was zero, and at certain time when the reaction comes to completion, so the product concentration reaches to its peak, that is 100%. Now, this gives me two curves. One is of product, another one is of reactant. Now, I can find out the instant rate. What is the meaning of instant rate? I can find out the instant rate at any particular time given to me. Like if my teacher says find out the instantaneous rate at 10 seconds, so I'll just draw a tangent. I'll make two perpendiculars. I'll get one concentration term and I'll get one time term. Okay, I'll just put it in the formula. I'll find out my rate. Okay, it is as simple as that. Okay, I'll just give you the points related to your instantaneous rate. Reactant decreases with time and products increases with time. As you can see this, I have also explained it to you. Tangents to the curve gives the instantaneous rate of the reaction. The instantaneous rate is represented by replacing delta by d in your average expression. What is d? D is nothing but the differentiation term. Okay. And chemical kinetics is concerned only with instantaneous rate, because we have to, because as a chemist, I want to measure my rate of the reaction at any point of my time. Okay. So this is all about your instantaneous rate. I would like to give you an example how to replace a delta and D term. So this is your reaction, okay? And the reaction is all about the decomposition of ammonia into nitrogen and hydrogen gases. The reaction is balanced by the stoichiometric coefficient, which are in the fractional values. It's okay. You can also write those values here, as I have explained it earlier. So rate is written as, in the average rate we used to write it as delta. Here we will write it as D. Rest everything it would be same, because NH3 is your reactant, so you have used your minus sign. Because N2 and H2 are your products, so you will not use any sign, because you know in maths we don't use positive sign to indicate any terms. Okay, if you write it, it is well and good. If you don't, then also it is okay. And dt is nothing but your change in time again. 1 upon 2, if divided, it will become, obviously it will come in the 2 will come in your multiples. and 3 by 2 when divided it will become 2 by 3. Okay, so this was a general example of your instantaneous rate. So now we'll go to the next part, which is your rate law. Okay, so what is rate law? Rate law is nothing but at a given temperature for a given time instant, the rate of the reaction depends on the concentration of the reactant. Now I'll first explain you what is rate law written as. Okay, so you can see the general form of the rate law picture there. The reaction was, I'm so sorry for that equal to, it is not equal to A plus B will give you, it should be arrow. So it is B will give you C plus D. Okay. So the rate law is written as, I define it, rate law is defined as, it is directly proportional to product of the concentrations of the reactant raised to some order. Okay, and you eliminate the proportionality sign, you know that we put an equal to and a constant term, which is your k. Now your k is nothing but your rate constant. Okay, uh, square brackets a square brackets b are nothing but your reactants. Okay, x and y are some values. Okay, those are some values which are known as exponents or orders. Okay, I'll explain you this in the other slides. It is known as exponents or it is known as order. Okay, so this is the rate equation. Now, uh, till now we were studying the average rate and instantaneous rate. Both the rate equations were same, but this is something different. Rate law is something different. You cannot see the product being used here, or the product is being used in the equation also here. So why this is important? Like if we can measure the average rate or instantaneous rate of the reaction, the thing which I wanted to know, the speed of the reaction, I can know by that also, no? By that instantaneous rate also, I can know it by the average rate also. But why we have to use the rate law? So what is the need of rate law? The need of rate law is knowing the rate law and expression relating to the rate, expression relating the rate to concentration of reactants can help a chemist to adjust the reaction conditions to get a more suitable rate. By this rate laws, we can adjust the conditions to get a suitable rate. That is, I can change the speed of my reaction and I can make it either fast or slow, whatever I have to do. Okay, and this is only possible if we study this rate law. So why we have studied that average rate and instantaneous rate? भाई बेसिक से जानना होता है, तो इसीलिए हम बेसिक से गए थे. बट वहाँ पे हमको सिर्फ नॉर्मल एक एवरेज रेट स्पीड मिल जाती है. यहाँ से हमको पता चलता है कि चेंज कैसे कर सकते हैं. ओके, so I'll again go with that rate term. Rate is equal to K, concentration of A, concentration of B, raised to X, raised to Y. Okay, I'll come with that thing again. Okay, because I have to explain you what is X, what is Y, and why we use that. Okay, so now you can see there that A and B, C, D, small are not used here. Capital C, capital D are not used here. That is, from the rate law, we are not at all concerned with the products. We are only and only concerned with the reactant part and not with the product. Rate law is all about your reactants and not of the products. Okay. So here you have a picture and you can see some examples. The examples, there are many reactions here, and the first reaction is uh, 2NO plus O2 will give you 2NO2, and you can see the rate equation. Okay, so I'll clear a thing over here that small a, small b cannot be equal to x and y. In many of these reactions, you will say that it is equal. Like in first reaction only, the stoichiometric coefficient 2 has come on the raised to part, एंड O2 में वन था स्टोइचोमेट्रिक कोएफिशिएंट, वहां पे भी वन है. But no, it is just an coincidence that has happened over here. You can see the next reaction itself. In next reaction 2H2 था, but वहाँ पे H2 के ऊपर 2 ऑर्डर में नहीं लगाया गया है. So orders and stoichiometric coefficients are never ever equal to each other. Why? Because stoichiometric coefficients are used, or they are put there when you balance your chemical equations, and orders or exponents that you use in your rate law are experimentally determined values. They cannot be determined theoretically, but your stoichiometric coefficients can be determined theoretically. Okay, so you have many such reactions over here. You can see one more reaction, the second last one reaction. You can see there that the order of the reaction, the order with respect to Br2 is written as half. So yes, the order can be anything. The conditions for the order is given in the next few slides. Okay. So this was all about rate law. I'll again just go through it. Rate law is nothing but it is directly proportional to the concentration of product raised to some order, and that order is not equal to stoichiometric coefficient. When you eliminate the proportionality sign, you come with a equal to sign and a constant. That K is nothing but your rate constant. Why there is a need of rate law? Because we have to set some conditions to get more suitable rate. Okay, so this was all about your rate law. This was all about your instantaneous rate. This was all about your average rate. Okay, so I'll come up with how exponents affect the rate of the reaction. That is, I just said you exponents are the raised to terms that we had seen in the rate equations, those x and y terms. Okay, exponents can also be said as orders, and basically in chemical kinetics we use the word order only and not exponents. So there are conditions. Suppose if x and y are equal to 1, we take the last equation only, last rate equation, rate is equal to k, concentration of A raised to x, concentration of B raised to y. So suppose that x and y both are equal to 1. If both are equal to 1, we don't have to write 1, 1 over there. It is understood that it is 1. Okay. Uh, so here the rate varies linearly with the concentrations of A and B. Everyone should agree with this. Okay, this was the general condition given over here. Now the second condition is for x is equal to 2. Suppose your exponent x is equal to 2 and your y is equal to 1. So the rate would be given as k, concentration of A raised to 2 and concentration of B raised to 1. Okay. Now, if A is doubled and B is kept as constant, rate increases by the factor of 4. Now, many of them will think that how it will increase with a factor of 4 if it is being doubled. So guys, let me tell you that if you substitute the value of A by 2, so 2 का square होता है 4 and it increases by the factor of 4. Okay. And here we compare what? We compare the initial rate and then we have doubled it. So we compare the two equations before doubling it and after doubling it. So the rate will increase 4 times of its initial value. Okay. Now the third condition is if x is less than 0, the rate decreases as concentration of A decreases. This is but obvious thing. If x is less than 0, it can be either fractional or any value. Okay. So if it is less than 0, the rate decreases as A increases. Okay. As the concentration of A would increase, the rate would decrease. The fourth condition here is if x is equal to 0, the rate would be independent of A. And this is a logical statement. Why? Because when we substitute 0 as an order in any term raised to 0 is equal to 1. Okay. And that term only eliminates from the rate equation. Okay, if you see the first condition, the rate law is given as rate is equal to K, concentration of A, concentration of B. If I substitute 0 at the order of A, okay, at the place of the order of A, so the value of that whole term will become 1. So it would be only depended on your concentration of B and not of A. So here we can say that rate is independent of A. Okay, so this was all about your exponents. Okay. Okay, so I'll come with your order of the reactions. Those were the conditions satisfying the rate equations, rate laws. Now I'll give you the conditions of what is order and what are the conditions followed by the order. Okay, सो सबसे पहले मैं आपको वापस बता दूं कि रेट इज इक्वल टू के कॉन्सेंट्रेशन ऑफ ए रेज टू एम. सो दिस इज फॉर अ जनरल इक्वेशन, ओके, जनरल रिएक्शन वेयर you had only your reactant A. So the rate equation for that reaction would be given as rate is equal to K. K is nothing but the rate constant, concentration of A. Again, I say square brackets for concentration, concentration taken in terms of molarity, raised to m. M is nothing but your reaction order. Okay, now these are some factors that affect your order of the reaction. Okay, so the order of the chemical reaction, sorry, is experimentally determined. I told you this in the last slide that orders are experimentally determined, but the stoichiometric coefficients are theoretically given. So those can never be same. अगर कोई reaction में same हो रहा है तो it is just an coincidence. Okay, कभी भी stoichiometric coefficient को order में मत लिख देना गलती से. The order can be integer, it can be fractional, it can be zero. Okay. Uh, uh, the last point is only a few third order reactions are known. Reactions with order higher than 3 are scanty. Why those are scanty? Because when your order increases more than when it becomes more than 3, the reactions become complex. And when the reaction becomes complex, uh, it comes up with many elementary steps, and those I'll not discuss here because you have to see those things in your chapter. So I'll discuss it later. But just keep in mind that order higher than 3 are scanty, they are not seen. Okay. So this is an example here. Rate is equal to rate is symbolized here as small r. Don't get confused. कभी rate लिखा है पूरा, कभी r लिख दिया. So you can write it as r also. Rate is equal to K, concentration of NO raised to 2, concentration of H2 raised to 1. You can see the reaction in the last slide. Okay, now this I would like to say that order here can be defined as this. So the order with respect to NO is 2. The order with respect to H2 is 1. The overall order of the rate is 3. Therefore, the order of the reaction is third order. Okay, now why I am telling this? Because it can be asked in your exams that order with respect, what is the order with respect to NO, what is the order with respect to H2, what is the overall order. Okay, so you have to define it specifically. Order with respect to NO is 2, order with respect to H2 is 1, but the overall order for the whole reaction is 3. Okay, I hope this part is clear. I repeat it again. When you have to say the overall order of the reaction, you just have to sum it up. You have to sum all the orders up and then you have to say the whole figure. Okay, like here 2 plus 1 was 3. So the overall order is 3. But the order with respect to a particular reactant is 2 or 1 or in the specific conditions, whatever it might be. Okay, so this was one of the few third order reaction for you. I just explained you all about the order, okay, and I also gave you the example of third order reaction. So by this, I end this topic here, okay. So thank you very much for your cooperation and stay tuned for my next videos, okay, for the next topics of chemical kinetics. I sign off. थैंक यू।